Already recording. Okay, come back to the whiteboard. I suppose that you see very well the whiteboard. Double angle. Double angle. Angle. Fórmulas, ¿no? Of identity. Okay, there you go. Okay, basically it's that formulas. Okay, I want to recopy again. Double angle. Look, double angle. The first one is sine double angle. Sine 2 theta. Double angle. Twice. The angle multiplied by 2 is equal to 2 times sine theta cosine theta. Multiplication. Is this formula. Okay, this formula is very, very, very important in calculus. Calculus 2. And what about cosine?
Professor, I don't know if it's only me, but I only see a blackboard, like a black screen.
Really? Wow.
It's you.
It's
Because
you.
I can see it.
Oh, okay, okay.
Entonces, what is the solution? Reload, or you go back, you go out and get inside again with the same link, no?
Okay, I'll do that. Thank you.
Yes.
Guess what? 2 options. Reload the page or... Noela, what is the solution? You can practice this.
I said she can refresh her computer. I did
Refresh.
That.
Okay.
Yeah.
Okay, the second inequality is a cosine, no? Cosine to theta, so double angle. We are talking about today double angle. We have, unfortunately, or fortunately, maybe because it's good, we have 3 possibilities of the cosine. Sine only 1, cosine 3. It's cosine squared theta minus sine squared theta. However, if in one problem you need to express everything using cosine or sine, we take advantage the Pythagorean identity, que is sine squared plus cosine squared equal 1. And suppose que, for example, you isolate the cosine, entonces cosine squared theta is equal 1 minus sine squared theta, and use substitution. Substitution where? In the cosine. Now cosine is not cosine anymore, it's 1 minus sine squared theta minus sine squared theta. Entonces 1 minus twice sine squared theta. It's another alternative equivalent, of course, of this identity is this identity. Similar, I don't want to prove again because it's the same idea. Another possibility, cosine double angle, is using just cosine, is 2 cosine squared theta minus 1. Actually, so we have 3 identity for the cosine. This is not bad. This is good because we have more possibilities. Sine, no. Sine, unfortunately, we have only 1. So the thing I try to explain in the cheat sheet, guy, I would like you be familiar, is this. Look, cosine double angle is cosine squared minus sine squared, or twice cosine squared minus 1, or 1 minus 2 times sine squared. Okay, this is a formula. This is a formula. Okay, we are using. And likewise, tangent. Tangent also. Tangent double angle. Tangent double angle is 2 theta. Is 2 times tangent theta divided by 1 minus tangent square. This formula is super easy derivate under the consideration que you have 2 angles, but it's the same. But I don't want to prove this. No, only application and that's it. Let's see a couple problems of the double angle formulas. and we continue to another formulas. Okay. Any questions so far? Example to understand more clearly. This is just a formula. Okay, see you have no question, so let's move on to the one example, no? To illustrate the application of the formulas. Example 1. Okay, let me remove this. Do you see the position of this? Well, no, it's okay. Make a zoom and forget about for a moment this page, because we come back again to this page. Okay, look. Suppose example 1. Example 1 say. Okay, you have sine theta equal 3/5. And theta is in second quadrant. That is a reason que sine is positive. Entonces I need to find sine to theta, double angle. I need to find cosine to theta, double angle. I need to find tangent to theta, double angle. Okay, to be in the second quadrant is equivalent to say que theta, so don't confuse theta and 2 theta. Theta is one hypothetic angle and 2 theta is twice. Suppose que theta is 30 degrees and twice is 60 degrees. To be in the second quadrant means that this angle is in between pi over 2, 90 degrees, and pi. Okay, it's 180. 90 degrees, this is equivalent degree. The student can prefer degree 180. This is the original theta. However, twice the double angle you multiply, if you multiply by 2 this complete inequality, actually we have 2 theta is in between pi and 2 pi. Therefore, it's clear the position of the original theta, but it's completely not clear, confusing, the position to theta because it's in between pi, okay, 180, and 360. Maybe it's in the third quadrant or in the fourth quadrant. So I am not sure what is the sign of this trigonometric function because definitely I don't know exactly in what quadrant lie. But don't worry for this, because if you apply the formula gives you the corresponding sign. You respect the formula. The formula give me exactly the final answer is positive and negative, and of course you determine in what quadrant lie double angle. Si es in the third or in the fourth. I have no idea. Okay, so I come back to the formula. Sine to theta is equal to time sine theta multiplication by cosine theta. I need to find cosine. It's easy. You are doing the triangle. This is my triangle. This is theta. It's given at the beginning that the sine is 3/5. So I infer that the opposite 3 and the hypotenuse is 5. And this is the famous 3, 4, 5 triangle, no? You know where I come from this 4 is square root 25, 5 squared minus 3 squared is 25, minus 9 is 16, and square root 16 is 4. Okay, it's the famous 3, 4, 5 triangle. Okay, we see before in another problem, no? Okay, so now the answer is 2 is a factor, sine is 3/5 because it's given. Multiplication by cosine, que cosine theta is 4/5 because it's adjacent over hypotenuse. But I know que theta lies in the second quadrant, therefore the cosine is negative. You respect the sign, you have no problem. It's 25. This is 2 times 3 is 6 times 4 is 24 minus 24 divided by 25 because 5 times 5 is 25. Entonces, the sign of the double angle is negative. Okay. Okay, no problem, I understand. Using the formula of the sine double angle. And you don't need to know exactly what quadrant lie. The formula give me the sign. Let's move on to the cosine. Cosine, que es the second thing they want. Cosine double angle. Is using the first formula, either way. Cosine square theta minus sine square theta. Cosine square is this. Is negative 4 over 5 square minus 3/5 square. This is positive 16 over 25 minus 9 over 25. And 25 is the common denominator, and 16 minus 9 is 7. Wow, it's 7 over 25 is positive. Now I find the conclusion then. Okay, our double angle lie in the fourth quadrant because in the fourth quadrant I know cosine is positive. And sine is negative. Okay, this is the conclusion. And what about tangent? Because the problem asked me 3 trigonometric functions. Tangent, well, okay. I can using the famous quotient or whatever you want to call tangent identity, tangent to theta is sine to theta divided by cosine to theta. So basically this trigonometry identity is valid for any angle and no exception double angle. Okay? Entonces basically you divide sine, que es negative 24 over 25 divided by 7 over 25. It's obvious that this 25 is cancelled. And the answer is negative 24 over 7. And we confirm it again that in the fourth quadrant tangent is negative. This is 7. Okay, the student that don't understand very well this division, you copy the first, que es negative 25 over 25. Time and reciprocal this is 25 over 7. 25 is cancelled. Stay 24 divided by 7 and negative 7. Well, professor, you are doing that way, but we can using another formula. Yes, what formula? That formula, tangent to theta is equal twice tangent theta 1 minus tangent square theta. Okay, that formula. That formula que we see before, that formula. Of course, in the test, or in the assignment, or in the thing you try to do, you need to do, you don't need to do several ways. I do for another way to double check and see everything is okay or not. Entonces tangent, okay, I need to find tangent, que I don't found. I find sine, que is given at the beginning. I find cosine, que is negative 4 over 5. I need to find tangent. I using again one more time the triangle maybe, or the identity, either way. It's opposite over adjacent. But of course negative because my original theta lie in the second quadrant. Okay, let's do it. Entonces 2 times multiplication negative 3 over 4 over 1 minus negative 3 over 4 again square. Well. These 2 and these 4 cancel out, and it's negative 3 over 2. 1 minus, this is 9 over 16. Of course, the negative inside the parentheses become positive and stay only the negative outside. Let's continue. LCD is 16. 16 minus 9. And 16 minus 9 is 7, no? is 7. And so far we have negative 3 over 2 divided by 7 over 16. Now division to fraction. Negative 3 over 2 stays the same and flip it out. This is 16 over 7. Use simplification a little bit. Divided by 2, 1. Divided by 2, 8. 8 times 3, 24 over 7. End the story. Same answer, different way. The way you prefer. Okay. Everyone follow me? Everyone understand very well this example? Clear or confusing? Hey, what? Answer me. Everything okay? Hey!
Yeah, that's right.
A little bit confusing, but we need more practice.
I know. Hello? It's the first example. Don't worry, relax. Okay, I promise. Okay, I have plenty example. Not only this part, all of them that we are covered here. I create a huge review. And I dedicate maybe 3 lectures for solving this review. Okay? Don't worry, only pay attention and try to understand. It's your job. My job is do the rest. Clear so far or no?
Yes.
Okay, beautiful. Let's move on to example 2. Okay, similar. Repetition again, similar idea. The most important thing is you apply the formula, okay? Plug it in. That's it. What about the signs? Well, the problem is normally the example, the information gets given is one trigonometric function and a specification the quadrant of theta, but never you see or you can find directly the quadrant of the double angle. I don't know, si lie in the second quadrant, in the fourth quadrant, in the third quadrant. Okay, again, compute the same thing. Example 2 say, okay, tangent theta is given. Tangent theta is given. S equal 1/2. And theta lie given in this way. And between pi and 3 pi over 2. And you need to find everything. Sine to theta, cosine to theta, and tangent to theta. Double angle. It's the thinking we practice now. Double angle. And the formula is twice sine theta, cosine theta. And the formula is cosine squared theta. One formula. We have 3 formulas for the cosine, but I'm using this because they're not necessarily using 3. Only one is equivalent. And this is tangent twice tangent theta, 1 minus tangent square. And tangent is given. Entonces, if you want, you start for this because tangent is given. By the way, in what quadrant lies theta? Theta lies in what quadrant lies according to this bounded and between pi and 3 pi over 2. Theta. In what quadrant lies theta?
Third and fourth.
Third quadrant. No. Okay. Look, this is 0. This is 90 degree. This is 180 degree. 270 degree. And this again is 360 degree. And the idea for the radian, this is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. It's obvious that this idea is in between pi and 3 pi over 2. Third quadrant, correct?
Yes.
This is the quadrant of theta. And what is the quadrant of the 2 theta? Okay, you know always is ambiguous. It's not clear. You multiply by 2 everything, entonces es in between 2 pi and 3 pi. Wow. 2 pi is here and 3 pi is here. Okay, 3 pi is equal pi. So any multiple, odd multiple of pi is equal pi. Because it's, so pi alone is 1/2 of revolution. 2 pi is 1 full revolution. And 3 pi is 1.5. So it's 1 revolution and 1/2. Actually, my double angle lie in between 2 pi and 3 pi. So I have no idea si es in the first quadrant. Oh. Si es in the first quadrant. Here. Oh. Si es in the first quadrant or in the second. Maybe it's in the first and the second. I want to investigate this. First one or second. Do you understand the idea, guys? I say always is ambiguous. You don't know exactly, but in the last moment, yes, you determine because according to the sign. Okay, let me start for the tangent to theta because the information is given in this problem is tangent. Entonces it's ready. Plug it in. It's 2 times 1/2 divided by 1 minus 1/2 squared. This is 1 divided by 1 minus 1/4. And 1 is 4/4 minus 1/4 is 3/4, no? I suppose. And reciprocal is 4/3. Pero I don't know si es positive or negative. Well, at least in this computation it's positive. But I need to verify this. Okay? It's positive or negative, eh? What do you say? First. Well, no, according to this idea, it's first quadrant, but no. No confirmation, guys. Let's do in sine and cosine, and we verify si es in the first or in the. Entonces you adjust the sign according to the quadrant. Okay, it's more strong to understand the problem doing first sine and cosine. Okay. Okay, entonces now suppose que sine, so my triangle look like that. Look, this is my famous triangle. Okay. Is opposite over adjacent. And the hypotenuse is square root 2 squared plus 1 squared. Pythagoras. 2 squared is 4 plus 1 is radical 5. This is radical 5. The hypotenuse is radical 5. Therefore, let me complete the collection of the trigonometric functions. Sine theta is opposite over hypotenuse. And que es equivalent, you know, radical 5 over 5, no? Rationalize. However, what is the sign of theta? Okay, I know very well in what quadrant lie in the third quadrant, no? The theta, no? To theta, I have no idea. I lost. So the sign in the third quadrant is negative. But this answer, I just the sign is negative. And cosine theta is the ratio between adjacent, que es 2 over radical 5. Y entonces rationalize is again 2 radical 5 over 5, no? But the sign is negative. Because sine and cosine both are negative. Okay? Let's move on to the formula. Sine double angle is equal to 2 times negative radical 5 over 5 times negative 2 radical 5 over 5. The answer is 4/5. Let me see. 2 times 2, negative positive. Entonces 4 radical 5 times radical 5 is 5. And 5 times 5 is 25. Then the answer is 4/5. 4/5. The tangent, bueno, entonces the sign es positive. Bueno, pero the sign is positive in the first quadrant y in the second quadrant. I have no conclusion for this. Okay, this is the answer for the sine double angle. Okay, now cosine double angle. Double angle is The formula, cosine square minus sine square. Cosine square is this guy, get negative 2 radical 5 over 5 square minus negative radical 5 over 5 square. This is, you know, this is positive f4, 2 squared f4 times 5 over 25, because 5 squared is 25 and the square root and the square power on those each other, minus 5 over 25. No? We can simplification a little bit, and this is the is 20, no? It's 20. No. We can simplification. 1 here and 1 here, 5, 4/5 minus 1/5, no? 4/5, 1 of my 5 is 3/5. And this is positive. Definitely, you're right. And the first quadrant, like my angle in the first quadrant. Because sine, cosine, and tangent are positive. So this answer, que I have a doubt, que I don't know very well, is positive. That means that our double angle lie in the first quadrant. Another possibility to compute the tangent is division. Tangent to theta is equal to sine to theta divided by cosine to theta. Cosine to theta. And sine is 4/5 divided by 3/5. The 5 cancel out, f4/3. Exactly the same, this answer of this answer. Okay, Okay, our angle, double angle, lie in the first quadrant, and everything is positive. Okay, everything is positive. Everything is positive. This is positive, and this is positive. Any question in double angle? No, don't try to see beyond this, because it's just this. The formula, and this is always ambiguous. In what quadrant lie, it's not clear. And the verification is you determine 2, not 4 interval, 2 interval, but in order to make a decision what interval lie, you compute any trigonometric function and go to the sign, so you decide what is the corresponding quadrant. Any question?
Professor, I have a question.
Sorry,
Professor. So I'm just wondering if for the first step that we need to do is to determine if it lies like on the first, on the second, the third, and the fourth quadrant, right?
Yeah.
Okay.
That's the first. Using this original inequality is given. You multiply by 2 in order to get the double. Super. Okay, let's move on to the half angle. Oh, this is different. It's divided by 2. And we have a collection of the formula of the half angle that is also used in calculus 2. Bueno, y en cálculo 1 also, no? Any trigonometric function can involve double angle or half angle. Okay, what is the formula for the half angle? This is the formula. Look. This is the formula. This, and that. Let me copy big here. Sine half angle. Theta over 2. Is equal plus or minus. You see, wow, so what is the sign? It's plus or minus? I want to explain the example. 1 minus cosine theta divided by 2. And everything inside the root. Cosine, half angle formula is equal plus or minus again. Square root is similar, 1 plus, but it's plus. So it's easy to remember. Divided by 2. You don't need to remember, no, but it's easy. And tangent half angle is this divided by this, no? When you divide, you get plus or minus again, a big square root 1 minus cosine theta divided by 1 plus cosine theta. Okay, it's a formula. This is the original formula. However, sometimes in calculus, this formula is used in different way. Because, okay, remember, the important thing is that this angle is a half of this angle. So another way to write the same thing is you, in order to eliminate the square root, you square both sides. So you have no sine anymore. You have sine square. Entonces, on the other side, we have 1 minus cosine divided by 2, no? Entonces, instead of theta over 2, you can call alpha. Suppose alpha here, and this is 2 alpha. And the cheat sheet called theta, exactly the same, but you are doing substitution, no? Suppose que alpha is theta over 2. Let's see, you put here alpha, this is double angle. There's another way to express the same formulas, half angle formula, alternative form. But okay. You need to understand, and basically in this lecture, we're using this one. However, in calculus 2, maybe you're using the alternative way. It's the same. It's cosine square alpha is equal 1 plus cosine 2 alpha divided by 2. And likewise, tangent square alpha is equal 1 minus cosine 2 alpha divided by 1 plus cosine 2 alpha. Okay? Okay, this is the formula. Nice to meet you. I understand. Now application. Okay, I bring 1, 2, 3 examples. Okay, let me try. Example. Example 1 of the application half angle. Okay, suppose okay, I need to compute the exact value of cosine 15 degree. Yeah, I have no idea. Well, okay, you put in the calculator, guys. So any angle that is not equal to the fundamental 0, 30, 45, 60, 90, 120, 135, 150, 180, but to 10, and so on, is the basic, fundamental, the name you want to call, is the angle that I suppose that the teacher believe que you memorize one day, no? But the other angle que is not fundamental, 15, I don't know who is that. You cannot memorize this. Entonces, always in the formulas y in the word problem, in the application, because guys, the chapter, next chapter, chapter 3, and also chapter 4, is application of this in the word problem, in the real life problem, no? Application, engineer, physics. So now, suppose you need to find cosine 15 degrees. You put in the calculator and that's it. But the calculator give me the decimal approximation. Well, the most of calculator, the majority of the calculator. Some calculators sophisticated, no. Give me the exact answer. But not the majority of calculator. Okay, so what is the idea? The idea is try to compute 15. I know that 15 is the half angle of 30. So we're using that formula. Look, that formula. That formula. I want to copy now. Cosine 15 degree. So I realize que it's plus or minus square root 1 plus, using that formula. Look, you consider in your mind que theta over 2 is 15 because I know que 30 divided by 2 is 15. Entonces 1 plus cosine 30 degree divided by 2. Okay. Entonces now Easy? Es obvio que 15 degrees lie in the first quadrant. Si lie in the first quadrant, no necessarily plus or minus. You put the positive only, right? In our specific problem, que I know, the quadrant que lie the original angle and the half angle both is 15 degrees, then the answer is positive, no negative. And the rest is plugging in. I know que cosine 30 degrees is 1 plus radical 3 over 2 divided by 2, no? And leave it like that, no? Well, this transformation is easy, or relatively easy. You, for example, the big square root, and you find the LCD in the top part. This is state 2, this 2 is this 2. And you have 2 plus radical 3. I suppose that you understand the thinking we're doing, right? You find the least common denominator, and you split that. 2 divided by 2 is 1. And radical 3 divided by 2 is 2. Now division is, let me see, let me do a division here. 2 plus radical 3 over 2 times 1/2. Okay, flip it that. Is 2 plus radical 3 over 4, no? Because 2 times 2 is 4. Entonces 2 plus radical 3 over 4. And leave it like that. No. We can, for example, separate square root 2 plus radical 3 divided by square root 4. And square root 4 is 2. Entonces radical 2 plus radical 3 divided by 2. And it's the answer. This is the exact value, okay, but when you put in the calculator give me the decimal approximation of this. However, sometimes happen, but this is completely irrelevant. Okay, the answer que offer the sophisticated calculator offer different answer. Okay, for example, 2 plus radical 3 over 2 is equivalent to radical 6 plus radical 2 over 4. Because using algebra, we can manipulate this expression in order to be, it's no nice, because you have one square root inside another square root, and we can manipulate, and you get that. I want to skip that part, because it's no too hard, but it's too long. To say, you want, I can explain, but in another moment. Okay, this answer is correct for me. Okay. This answer is correct for me. Okay. So just apply the formula, and you, of course, you determine the sign, que es plus or minus, and depende de quadrant, que lie the half angle, que 15 lie in the first quadrant. Therefore, the cosine in the first quadrant is positive. Okay. Okay or no? No. Complicated.
Okay, Professor, I have a question. When we change, we put cosine of 30. It means because it's 30 is divided by 2, that is 15, right? That is why you put 30 like in the. Yeah, okay. Yeah.
Using the formula, Noela. In the formula, you see theta and theta over 2. In our specific.
I'm using the sheet that you sent to us. Like, I'm just wondering, where is it? Okay, I found it. Thank you. Never mind.
In our specific example, Noela, theta over 2, que es this guy, is 15 degrees. This is 15 degrees, and this is 30 degrees, right?
Right, Professor.
It's don't try to see it. This is no complicated. It's weird, I know, but it's no big deal.
Okay.
Let's see another example to understand. I bring two more. Two more similar to the topic we covered in the review package, no? Okay, I want to erase this part. I don't want to erase this page because we continue using this. Example 2. of the half angle. Let me erase that part. Okay. Example 2. What is the information given in the example 2? It's given the sign. Sine theta is equal to 3/5. And it's giving que theta lie in the first quadrant. Pero I have no idea. Well, I suppose using my imagination que theta over 2, see theta lie in the first quadrant, theta over 2 lie also in the first quadrant. But okay, what is the efficiency way to do this? Look, let me translate this to inequality. Theta lie in the first quadrant means que theta is in between 0 and pi over 2. Therefore, theta over 2, que is a half angle, you divide by 2 everything. 0 divided by 2 is 0. 0 divided by 2 is 0. And this is pi over 4. Divided by 2 is pi over 4. Wow! So say now my theta, let me try to make a sketch to understand. My theta is in the first quadrant here. This is the location for theta. Theta lie in the first quadrant between 0 and pi over 2. This is theta. However, theta over 2 is a half angle lie in this piece of the first quadrant, que is in between 0 and 45 degrees, que is pi over 4. This is the region for the half angle. That means que both are lie in the first quadrant. So any trigonometric function that we found, we're using in the formula post design. Okay? Entonces now, suppose sine theta over 2 is equal square root 1 minus cosine theta divided by 2. It's a formula. But I put the positive sign here, no negative, because I know I verify that both theta and theta over 2 is important, lie in the first quadrant. Therefore, you take the positive value, not the negative value. And likewise, cosine theta over 2 is equal to square root 1 plus cosine theta over 2. Pero I need cosine. Okay, but it's easy. You are doing the famous triangle. This is theta. This is 3, this is 5, and this is 4. Therefore, cosine theta is 4/5. Let's do it. Square root 1 minus 4/5 divided by 2. Okay, one efficiency way to compute this complicated fraction and roots and something is multiply. In order to eliminate the fraction, you multiply by 5, top and bottom. Entonces, square root 5 minus 4 divided by 10. Look, you multiply 5 times 1 is 5, and you multiply 5 times 4 over 5, you cancel out the 5 and 4. So the answer is 5 minus 4 is 1. Entonces radical 1 over 10 es radical 1 over radical 10 es 1 over radical 10. Rationalize radical 10 is radical 10 over 10. And of course positive value, because I know very well that my half angle lie in the first quadrant. Let's do the formula for the cosine half angle. Que es similar, except que es plus 1 plus 4/5 divided by 2. And we apply the same technique, multiply by 5. This is fantastic because allow us eliminate the fraction. 5 plus 4 divided by 10 is square root 9 over 10 And this is square root 9 over square root 10. Square root 9 is 3 over radical 10. Rationalize is radical 10 is 3, 3, 3 radical 10 divided by 10. And both are positive because they have angle lie in the first quadrant. Super good, super good. Any question, guy? Half angle.
Professor, the only part is when, can I ask you a question, Professor? Can you hear me?
See, I hear perfectly.
Yes, Professor, I'm just wondering, like, if the theta is in the first quadrant, we can just like put everything positive, right?
Yeah, absolutely. But
Okay.
remember, our goal is not theta now. It's theta over 2, half angle. So we focus in the computation of the half angle. But you infer using the inequality, compound inequality. Okay, if theta lie in the first quadrant and you divide it by 2, theta over 2, que es half angle, also lie in the first quadrant. So any trigonometric function that we compute is positive. Clear or no?
Yes, it is, Professor.
Okay. Let's move on to example 3. It's a little bit more interesting because I know the first quadrant. Suppose example 3 say cosine theta is given is negative radical 6 over 3. And theta is the original theta is in between pi over 2 and pi. Entonces now let me try to understand in what quadrant lie theta. Please help me to understand this.
We need to double first now, Professor.
What do you say?
We need to double first because...
No, not yet, okay. I focus in theta, not in theta over 2, no half angle. No, in theta. Theta is in between pi over 2 is 90 degrees and pi is 180. In what quadrant? My question is, in what quadrant lie theta?
Second?
Absolutely. Here. This is theta. Theta lie here. This information is given. Well, now you need to compute a half angle. So my goal is compute sine theta over 2 and cosine theta over 2. And this is always confusing because the formula have plus and minus. And I don't know what sign I need to use. Now, in order to find what sign I need to use, you take this inequality and you determine theta over 2. How? Divided by 2. Divided by 2 is pi over 4. And divided by 2 is pi over 2. And now let me try to make a sketch for the theta over 2. It's pi over 4. Get here. This is pi over 4 and pi over 2. I suppose that theta over 2 half angle lie here. Yes or no?
Yes.
And this lie in the first quadrant. Therefore, any trigonometric function is positive. So now, immediately, you don't need to write double sign. No. Only positive because I discover theta over 2. This situation is completely different. Let me take advantage this example to illustrate half angle and double angle. But no, okay. Let's focus in half angle first. So do you understand very well that the formula that I'm using now is square root 1 minus cosine theta divided by 2. And using positive sign here. Okay, by default, when you omit it's missing it's because it's positive, no?
Yes.
Excellent. Okay, let's do it. Entonces, square root 1 minus, pero cosine theta, it's given, look at that. Es negative. Entonces, doble negative, negative of the formula, and negative of the value become positive radical 6/3 divided by 2. Correct? Correct?
Yes, Professor.
Now multiplication by 3 and by 3 here, because I want to eliminate the fraction. So we have a big square root, we have 3 plus radical 6 divided by 6. And it's living like that. We can manipulate more, but no, this is crazy. This answer is perfect, and this is the exact answer. And of course, positive, because I discovered que half angle lie in the first quarter. Likewise, the cosine is similar. It's 1 plus, but this is negative radical 6/3 divided by 2, ¿no? Entonces, square root 1 minus radical 6/3 divided by 2. Similar, I multiply by 3 top and bottom in the same fraction. Multiplication by 3 here, multiplication by 3 here, and the answer is square root 1 minus radical 6. No, 1, no, sorry. 3 minus, because 3 times 1 is 3, minus radical 6 divided by 6. And also positive, because the half angle lie in the first quarter. Okay. Entonces, I want to take advantage to investigate curiosity, just curiosity. Sine to theta, double angle, and cosine to theta. Okay? No tangent, only sine, cosine. The formula is 2 sine theta, cosine theta. And this is cosine square theta minus sine square theta. In this case, you don't worry for the quadrant, because the formula gave me directly what is the quadrant. And the half angle, no. The half angle, remember, we have plus and minus, and you need to analyze geometrically to decide if you select the plus or you select the negative. But in this, no. This is nice. You plug it in, and that's it. And after, by curiosity, you let me know in what quadrant lie the double angle. Okay, I have no idea. And then I need to get in my hand sine and cosine of the original theta. So I do the famous triangle. Two, this is theta. And this guy is radical 6, and this guy gets a hypotenuse 3. And this sine is obvious que es negative because theta lie in the second quadrant, and I know very well que sine is negative in the second quadrant. The cosine, sorry, is negative in the second quadrant. To find the opposite sign, you apply Pythagoras. 3 squared minus radical 6 squared. 3 squared is 9, and radical and square cancel out each other, is 6 is radical 3. Therefore, sine theta is opposite que radical 3 divided by hypotenuse, que es 3. Super. And this guy is positive because no problem. I take care only the original theta. And the information for the double angle is given when you finish the problem. Entonces, 2 times sine theta is radical 3/3 times cosine theta is given at the beginning, no? A radical 6/3. And so we have, let me see. Wow, this is 2. This is negative, of course, because positive and negative together is negative. Okay, and this is radical 18, maybe, no? Because 3 times 6 is 18 divided by 9, no? 18, I know que es 2 and 9. And radical 18 is radical 2 and radical 9, que es 3. So radical 18 is 3, radical 2. Ok, entonces -2 times 3 radical 2 over 9. And then the answer is, when we cancel out this 1 and this 3, is -2 radical 2 over 3. So the sine double angle is negative. Wow. Okay. So maybe double angle lie in the third quadrant or in the fourth quadrant. I have no idea. Let me determine the cosine, and you confirm me what quadrant lie double angle. Okay, let me try to do my best. Cosine square is a negative radical 6 over 3 square minus sine, que es radical 3 over 3, es radical 3 over 3 square. This guy is positive. This is 6 over 9. Minus, this is 3 over 9. Okay. Entonces, 6, bueno, 9 es el common denominator, ¿no? Es 6 minus 3 es 3. Wow, es 1/3. Wow. And the cosine is positive. And sine is negative. Therefore, my fantastic conclusion is double angle lie, look, here in the fourth quadrant. This is the position for the 2 theta. Because the sine is negative, and cosine is positive. Make sense? Beautiful.
Yes,
It's super easy. It's super easy, the manipulation of this equation. No sophisticated. I promise. This is the first lecture, no, of that part. Entonces now I promise que in the next time we start review and we cover a lot of problems of this. And we training to you in the double angle, half angle. But the most important I want to say, I want to summarize is que the double angle formula, you don't need to know at the beginning in what quadrant lie double angle, because it's ambiguous. Entonces you plug in the number directly in the formula, according to the sign you determine the position for the double. Half angle, no. Half angle, you have two possibilities, plus or minus, and you need to analyze first in what quadrant lie. But it's easy using the inequality. Any other question? Clear or confusing?
Professor, my question is at the beginning. We have sine of theta over 2, and then, Professor, you substitute and it was positive, but in the formula is negative. It's because it's like plus and minus before?
Yeah. Actually, the thing I'm doing, you say in that part, Nuela, no?
Yes, Professor.
Don't worry. It's square root 1 minus something. And minus something is minus radical 6 over 3. Divided by 2. But this negative and this negative together become positive. So I skip this step and put directly positive. Make sense?
Yes, it does. Thank you, Professor.
Likewise, in this part is square root 1 plus negative radical 6 over 3 over 2. And positive and negative is negative like that. Be careful. This is detailed. See, you know, mathematics is horrible. One sign can you omit or you are doing wrong, everything is screwed up. Okay?
Yes, Professor, thank you.
The rest of the time, I want to discuss in two kinds of the identity that we don't use it frequently, but maybe you need to know in calculus. Okay, it's the conversion. Look, that part. So you covered that part the previous class. But now I cover this, I cover that. This is product to sum. Product to sum. Entonces, este conversion, when you have product multiplication, two trigonometric functions. Suppose. I want to copy only one. Suppose that you have sine multiplied by sine. Sine alpha times sine beta. Alpha and beta is two different angles, no? And it's a product multiplication. And you convert, because it's most convenient in calculus, maybe, express it like a sum of differences. In this case, cosine alpha minus beta. I try to copy this. Minus cosine alpha plus beta. Everything divided by 2. Or multiplied by 1/2. Either way. Okay, this is conversion product to sum in that direction. Okay? I want to see not too much, but some example. Because in calculus, when you are doing something, in this case, horrible. However, in this case, super easy. Okay? Now, in opposite direction, we have sum to product. Sum to product in this direction. It's opposite to this, no? Okay, is you have the sum of the two trigonometric function and you convert to the product multiplication to trigonometric function. Suppose taking the first one, sine alpha plus sine beta. And the formula say that this is equivalent, 100% identity, guy, to sine alpha plus beta divided by 2 inside the parentheses times cosine alpha minus beta over 2. Now the conversion in this formula is sum. You start in sum and you convert to product. Sum because of plus or minus, no? Depending, it's sine. We have 4 combinations: sine plus sine, sine minus sine, cosine plus cosine, and cosine minus cosine. Okay? This formula, nobody remember. This formula is horrible. Okay? But you keep in mind in your future study, for example, when you're in calculus, you are doing integration. It's the famous integration. Nobody can do that in product. No, crazy, impossible. However, in separate and sum, it's possible because this operator is linear and you can separate each other. And in this case, it's another. It's in the opposite direction, no? So you need to understand in physics, for example, when you study wave, you have to wait, and you need to understand that this weight together, when you intersect in the weight, is equivalent to this, and your interpretation this is another kind of weight. This is travel weight, and this is the another kind of weight. So this is a formula that we can use in different subjects: sine, calculus, to conversion, product to sum, or sum to product. Of course, I bring a couple of examples of this, and that's it, because it's too easy. It's no big deal. Example, a couple, and that's it for today. Well, let me see. Look, example 1 of that part. Suppose que is giving sine 6 theta multiplication sine 4 theta. It's a product. However, I need to convert as a sum. Entonces, what is the formula que I use? Bueno, I use that formula. Let me copy the general formula. Es the product of sine, o sea, sine alpha times sine beta is equal cosine alpha minus beta minus cosine alpha plus beta divided by 2. Pero who is alpha and who is beta in our specific example? Look. Es no alpha, no beta. Es 6 theta and 4 theta. It's the same variable, pero different multiplier. It's easy. Entonces, cosine, and you put inside subtraction 6 minus 4, que es 2. Minus cosine, and you addition 6 plus 4, que es 10. Theta, of course, divided by 2. This is equivalent. And this is easier in calculus than this. Okay? Another example. Example 1, example 2 is, for example.
Sorry, Professor, we just substitute, that's it?
That's it.
Oh my God, it's easy.
See, no, always is complicated, no? Suppose cosine 3 theta time cosine theta. Entonces de fórmula cosine, multiplication cosine es cosine alfa time cosine beta. De fórmula 6 es cosine, es plus. Es de same fórmula, pero es plus. Cosine alfa menos beta plus cosine alpha plus beta divided by 2. In our specific example, alpha is 3 theta and beta is just 1 theta. Entonces es 2 cosine subtraction 3 minus 1 is 2 plus, because it's plus the formula, and addition is cosine 3 plus 1 is 4. Okay? It's unbelievable, but it's true. You convert multiplication to addition. Okay? Or backward. This is a product to sum formulas. And sum to product is, suppose. Okay, we have example 3 and example 4. And that's it for today. Example 3. Suppose que we have sine 5 theta minus sine 3 theta.
Sorry, Professor. And the example 2, why we have a 4 if we have cosine of just theta, we don't have a 4? Or you forgot to put the 4? On 4. Example 2, you said we have cosine of 3 theta, and then we have cosine of theta, and then you substitute and you put 2.
Voy a confront these two, Noela. Es 3 theta minus theta. Voy a confront this 4 theta. 3 theta plus theta.
Okay. It's another formula. Okay, thank you, Professor. I was confusing.
Okay, so now I have completely different order. We have sum of differences. It's the same. Two product. The formula I apply in that case on the sine minus sine is, I want to copy the formula, the general formula, and you apply in a specific example. Sine alpha minus sine beta is equal to time sine alpha minus beta divided by 2 multiplication by cosine alpha plus beta divided by 2. Entonces our problem is alpha is 5 theta, sorry, and beta is 3 theta. This is equal to 2 times sine, and you adding no subtraction, sorry. 5 minus 3 is 2, divided by 2 is theta, 1 theta. Cosine something, addition, 5 plus 3 is 8, divided by 2 is 4. End of story. Do you see or no?
Yes, Professor.
One more and that's it, the last one. Example.
Professor, you said that this one was the last one.
Bueno, yeah, I say a couple more, no? A couple more is 2, no? You say 2 more tomorrow. Okay. One more easy. 3 theta plus cosine 2 theta. Sum to product. The formula cosine con the plus is cosine alpha plus cosine beta is equal to time cosine alpha plus beta, so over 2 times cosine alpha minus beta over 2. Entonces 2 times cosine, and you find the addition is 3 plus 2 is 5 divided by 2 is 5 over 2. 5 theta over 2. Multiplication by cosine. Cosine what? Cosine is subtraction. 3 minus 2 is 1 divided by 2 is theta over 2. End the story. That's it. So basically, it is no big deal. It's conversion. Guys, and you finish every formulas in trigonometry. Well, we have more, but now we are ready in the next chapter to application this in the real life. Okay, engineer, physics, basically, but this subject. I bring the fantastic collection of the word problem, and you need to use your imagination and your common sense. Okay, any question? Any question? Any question? No, 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 no. We
Professor, sorry. When is our next test?
In the syllable you see, February something, February 24, right? You see in the syllable. I follow it strictly the syllable, right?
Okay, I'll go there. Thank you. Have a nice day.
You too. Guys, bye-bye. Okay, love you, love you.